Now, what's interesting is people often think quantum mechanics, you have something called the
Right.
uncertainty principle, and like the electron is jumping around in some fuzzy way around the proton. But it turns out quantum mechanics doesn't work that way. It's actually a very, very
Hmm.
precise motion. Okay. And the motion is through something physicists study called
Right.
waves. And for example, if you pluck a guitar string, there's going to be a wave in that, and the guitar string is oscillating back and forth in a
Hmm.
certain pattern. Okay. And at the two ends of the string, it's not moving at all, and kind of in the center of the string, it's
Right.
moving the most, if you're looking at that. And it turns out that matter and electrons kind of behave in the same way, where they have this, what we call a standing
Mm.
wave pattern, like a guitar string. And it's a very well defined kind of oscillation, just like the note has a very well defined frequency in a string.
Right. But this is kind of different here because we're talking about a wave that relates somehow to probability, the probability that if we measure it, it's going to be in one specific place, right? Is that correct?
That's right. So if you look at the
Yeah.
guitar string analogy, then
Hmm.
where the wave is the biggest, it would be the most probable to be there. And at the
Hmm.
ends of the strings where it's held tight, then the probability is going to go to zero at the two ends. So
Right.
there's this strange, kind of thing you have to understand about quantum mechanics, that the kind of the amplitude of the wave tells you the probability. And then that's kind of the fuzziness, is that this wave has some extent, across the atom.
Right. Exactly. So the wave function basically decides sort of where it might be, and but we don't know actually what's going on.
It's very well defined
Yeah.
wave property. And, people make atomic clocks out of these oscillating waves that are
Hmm.
accurate to a part in, I don't know, 10 to the 16 right now. It's very, very
Hmm.
accurate,
Right.
extremely precise. And in some sense, it's some of the most precise things we know about nature
Hmm.
is how well defined these oscillations are and these waves are. It's really kind of
Right.
remarkable how that works.
Yeah.
If it's very well defined, and we know the mathematics on how it's well defined,
Mm.
then we can use that phenomenon for doing precision experiments and measurements. So you make
Right.
clocks for your GPS and you build a quantum computer out of it, because the motion of these quantum systems are very, very precisely known and can be predicted. And one can
Mm.
build a whole logical structure out of that.
Right. So basically, this is how I understand it. You don't actually know what happens when you're not actually measuring where the electron is.
Well, that
But
actually, let me be a little bit more precise, okay?
okay.
What
Yeah.
happens is you manipulate this state, and
Hmm.
it's obeying quantum mechanics, and you actually know what's happening with it. You can predict it. There are mathematical equations
Yeah.
and all that. So it's extremely predictable, which is, of course, what you
Right.
need
Yeah.
for a computer.
Yeah.
However,
For
you
sure.
go measure it and you want to know, okay, what's really going on with the quantum system? Where is the electron?
Yeah.
Then when you measure is where you have uncertainty. It can be sometimes here or
Mm.
sometimes here.
Right.
So
Yeah.
so what happens is you can predict what's happening with the quantum system very,
Mm.
very precisely, until you go ahead and you try to extract information and measure it, and then you
Right.
you get a probability out of it.
And it's that prediction that we know something about, right? It's that prediction that we're precise about.
That's right. And what
Right.
happens with the prediction, since it can have several outcomes, you get a probability. So sometimes it's going to
Mm.
be here, but sometimes it's going to be here. And when you
Mm.
measure it many, many times, you get some probability distribution, and that you can compare very precisely with theory.
If you have a question for John, just write it in the comments field before the end of July 2020. If you liked this video, why not make it official? Press the subscribe button and then the bell beside it. And while you're doing that, why not also open your window and shout out the name of my channel? Stir-fried fascination! Thanks for watching, and see you in the next one.